In class. I'm Mr. Wilson Akadu, taking you biostatistics. So I'm welcoming you to the class, and we are starting the class. Please, if you are attending the class, you send your name, your username, and also your center, your location. Okay, now what is biostatistics? Biostatistics is a branch of mathematics responsible for interpreting the scientific data that is generated in the healthcare, including public health sector. So, like what we are saying here is that all the data is being collected in healthcare, public sector, the hospitals. These are what? When we now make use of all these biostatistics, we collect the data, then we're talking about what? Biostats. Now, it is the responsibility of what? Statisticians and other experts to consider the variables in subject in public health and others like that. Now, biostatistics has made major contributions in countless public health sectors, such as when we go to the chronic health diseases, the data you are getting, go to the cancer, the human growth and development, the relationship between genetics and environment, and also in AIDS and health environment. Now, biostatistics is what? And it is integral in the advancement of knowledge, and not only in public health sector, but also in biological sciences, in health policy, clinical medicine, health economics, genomics, and other disciplines. Now, what are the work of biostatisticians? Biostatisticians are responsible to develop statistical method for clinical trials, observations, studies of longitudinal studies, and genomics. Now, biostatisticians help us to validate data in the health sector. Now, we can see that I'll be talking about data, you're talking about data. What is data? Let's go down to what is data. What are data? Data can be classified in two ways, either by types and by level of measurement. Either by types and by level of measurement. Data by type, we are talking about qualitative data and quantitative data. From your research methodology, you have been taught that qualitative data, we have qualitative data and quantitative data. Now, for those of us writing projects, when you come to areas where you are giving out your questionnaire, you want to collect data for your project, and then you are giving out questionnaires. By the time you come to those places that you see like qualities, okay, you are talking about gender, and you are giving somebody, you should tick the gender will be male or female. And we are talking about okay, for example, maybe you are writing about private hospitals are better than public hospitals, and you are now writing under that, you are saying, do you agree, disagree, strongly agree, disagree, things like that. By the time you are collecting, they are taking, what you are collecting is qualitative data. But by the time we now come to counting how many people are male, how many people are saying they agree, how many disagree, how many this, how many that, then you are now going to quantitative data. That is, qualitative data consists of attributes, labels, or non-numerical entries Then quantitative data consists of what? Numerical measurement or count. Now let's go to level of what? Measurement. We're talking about levels of measurement. There are 4 levels of measurement in their order from the least to the highest. We are talking about what? Nominal data, ordinal data, internal data, and ratio data. Now let's go to types of statistics. We have 2 types of statistics. We have descriptive statistics and inferential statistics. So the descriptive statistics is talking about, is broken down into our measures of dispersion, measure of central tendency, our charts, our graph, our shapes of what? Distribution. What is what we are talking about data. What is now? Let's go to sampling. What is a sample, or what is sampling? Now, a census is a count or measure of what? An entire population. Taking census now is what? Is cost effective. But most times it is difficult to take census. And the last time we did census in Nigeria was 2006. Supposed to be done every 10 years. So the government could take data, they know area that is densely populated, sparsely populated. They know how to do their planning and how to share revenue. But because it is costly effective, that is why for some years now, census have not been done. So you can see that for some time now, in your places, you see that they have been resolved to sampling. So some years back, some census officials were going around. You see where they will write N in front of your house, NP slash so number slash. So they are taking samples. And what are samples? A sample is a measure or part of what? A population. A sample is a subset of what? The population. So a sample represents what? The population. From the sample, you can take what? Your estimation. You can conclude over what? A particular what? Population. Let's go down to our school, ISQ JPTS. We know that for example, you are talking about a particular level, 400 level second semester. If I'm taking 400 level second semester, that is what? A population. Now, each department in that level, we have the healthcare department, we have the engineering, we have we have computer engineering and software, we have mass comm, we have theater art, we have biz admin, we have economics. These are what? Subsets of what? 400 level second semester. So each of those 400 level departments, second semester, are what? Are a sample from the population. Now, talking about a particular school, you can take it to be what? The population. Then each level, 100 level first, 100 level second, 200 level first, 200 level second, 300 level first, 300 level second, 400 level first, 400 level seconds. These are what? Samples, parts of what? The population. Now, definitions like, let's go to definitions like sample unit. The sample unit represents what? The participants. They will talk about sample frame. This represents the access to sample or where the sample is being drawn from. Then sampling error. Sampling error is the difference between the result of the sample and that of what? The population. the sample frame error. This represents elements that could not be taken or accessed or unavailable during what? The course of study. Then how do we choose a sample? How do we choose a sample? One, by listing the research goals. You identify the potential sampling methods that might be what? Effectively achieve your goals. Then two, you test the ability of each method to achieve each goal, and also choose the method that does the best job in achieving what? Your goals. Next is, let's go to sampling, method of what? Sampling. There are different sampling methods. There are two main methods of what? Sampling. One, the probability sampling, and the non-probability sampling. And let's go to the probability sampling. Probability sampling is a method set up that assumes that different units or participants in the population, they have equal probability of equal chance of being selected through a random selection. That is, the probability, if, for example, I have, okay, let me take JPTS Ikorodu for an example. Each department, each level serves as what? The sample there, which is what? 100 level first semester, 100 level second, 100 level, 200 level first, 200 level second, 300 level first, 300 level second, 400 level first, 400 level second. Now, the probability of me picking somebody from 100 levels first, how many do we have? We have 8 of them, is what? 1/8. The probability of me picking somebody from 200 levels second is still what? 1 over what? How many samples do you have there? 8. So all of them have equal chances of being what? Selected. So that is what? Probability sampling. And probability sampling is divided into different types. One, we have what? The simple random sampling, the stratified random sampling, the systematic random sampling. We have the cluster random sampling, and the what? Multi-stage random sampling. Now let's go to non-probability method. Non-probability method is a technique that samples are being selected based on what? Subjective judgment of the researcher. Maybe the researcher wants to take a particular, wants to deal with a particular area. So instead of him giving equal chances to different areas, he has a particular area he wants to take. So he's speaking from that place, ignoring other places. So that is what? A non-probability sampling techniques. Rather than selecting from every aspect, every different areas, that is, each of them, they don't have a particular, there's no equal chances of others being selected. It has preference to a particular what? Area. The method of non-probability sampling are the quota sampling. We have the convenient sampling, the purposive sampling, the snowball sampling. The snowball sampling. Now, moving to our descriptive statistics that we talked about. Statistics, we said divided into two. We have this descriptive and inferential. And under descriptive, I said we'll be looking at our scheme covers the measure of central tendency, measure of dispersion, charts, and shapes of what? Distribution. Now let's go to our charts. From your 100 level first semester, computer and stats must have another level second semester, computer and stats must have done your mean, median, mode, which is what? Our measure of central tendency. Then our charts from our secondary school work, our pie charts, bar charts, histogram. I'll just run a quick view of each of those charts. Now, under charts, we have what? The line graph. The line graph. The line graph is representing data what? In lines. In lines. Then from there, we have our bar charts. Our bar chart, this is the representation of data in bars or rectangular bars with height proportional to the value, proportion to what? The value they represent. Now, in bar charts, each of the bars are equal, but there are distinct spaces between them. The spaces between each bar are also what? Equal. When doing exam, you have to make sure that your space between each bar are what? The same. The length of a particular bar should not be bigger than the other one. Another one should not be smaller. They should be what? Equal. Now let's go to our histogram. Histogram is the graphical representation of what? Group frequency distribution with continuous classes. That is, the bars are what? Closely joined together. In bar charts, we said that what? The spaces are what? Equal. But in histogram, they are what? Joined together. That is why in histogram, we make use of what? Our class boundaries. Our class boundaries. We make use of what? The class boundary. Then the pie chart. The pie chart is a type of graph representing data in what? In circular form, with each part representing a fraction part of the what? The whole. The pie chart is telling us that what? Representing the parts in the whole. That is each of those parts, which is our sector. Then the whole is what? The circle. The total of the pie chart is what? 360, because angle at a point is what? 360. So the total distance of a circle is what? 360. So you have the total. You are given a particular problem. You find your total. Then getting each of those your pi, what you are solving for will be over your total times what? 360. Let's go to our measure of central tendency. Measure of central tendency. The measure of central tendency is a measure that indicates where the center of most typical value of a data set lies. The most commonly used center of tendency are what? Our mean, our median, and our what? Our mode. Our mean, median, and mode. Now, the mean and the median can only be applied to what? Qualitative data, whereas the mode can be used either in qualitative and what? Quantitative data. Now, what is our mean? We already know. Another word for our mean is what? Average. The mean is a commonly used measure of central tendency. It is defined as the sum of the data divided by the number of data. The sum of the data by the number of data. That is, it is summation x over n. It is summation x over n. Now, our median. Our median, the median is what? The middle number of the data of a data set arranged in an ordered set. That is, if you are given a particular problem, for example, let's solve, you are given 22, 20, 24, 21, and 25. What is our median? I know majority of us will run to take 24. No. You are supposed to what? First of all, arrange it in what? Ascending or what? Descending order. By the time you arrange it, our list there is what? 20, 21, 22, 24, 25. Then the most there is what? 25, 24, 22, 21, 20. So what's our medium number there? Our medium number, our median there is what? 22. So our median is always what? The middle number after you have arranged it in an ordered set. Either what? Like that you've been taught before in primary or secondary school, you're what? Ascending or what? Descending order. Now let's go to our mode. What is our mode? Our mode is what? The most occurred number in the data set. You can also say it's the number with what? The highest frequency, or the number that occurred most. So that gives us what? Our mode. Now this goes with on group data. But when we have group data, there are ways by which we solve group data. Now our group data, let's go to mean of group data. The mean of group data is given as what? The mean, which is x bar equal to summation fx prime over summation f. When our x prime is what? The midpoint, the mid value of each of what? The classes, each of the class interval. So when a problem is given in and you're asked to put it in group, or you're already given each of the classes or class intervals, when finding the mean, you must also find what? The midpoint, or the class what? Center. The class center, or what? The midpoint. Now let's go to our mode of group data. The mode of group data is given by the formula mode equals L1 plus bracket open D1 over D1 plus D2 close bracket multiplied by what? C, where our L1 is the lower class boundary of the modal class. Then our D1 is the difference between the modal frequency and the frequency before it. D2 is the difference between the modal frequency and the frequency immediately after it. Then our C is our what? Our class size. Our C is our what? Class size. Therefore, I'll share the material with you, and then you will see different examples, solved examples there. Now let's go to median of group data. Median of group data. The median of a group data is given as L1 plus bracket open n over 2 minus CFB all over F subscript M, close your bracket, multiply by C, where L1 is our lower class boundary of the median class. Our N is the total frequency or the sample size. Then our CFB is what? The cumulative frequency before the median class. Our F subscript M is what? Frequency of the median class. And our C is what? Our class size. Our class size. There are also examples in the material. You see it there. So let's move with, let's go to the next is our measure of dispersion. When we talk about measure of dispersion, we're talking about what? The degree of spread of a data set. That is, what are we saying here? Is the degree to which a data is being scattered or dispersed about the average value. It is also what? The amount of variation or spread in a data set. Examples of measure of dispersion are, we have been asked, give 4 examples. There are many examples. One, range. Our range. 2, our mean deviation. Our what? Our standard deviation. Our interquartile range. Our variance. All these are what? Examples of what? Measure of dispersion. Our mean deviation. Now let's go to mean deviation. The mean deviation is the degree. The mean deviation is giving us our mean deviation. Our mean deviation is giving us what? Summation modulus x minus xi all over n. X minus xi over n. Where there is a frequency, it becomes summation f modulus x minus x subscript I over what? Summation f. Where our modulus, the meaning of the modulus means what? All negative numbers becomes what? Positive number. So modulus is what? Absolute number, absolute value. There are no negative value in what? Modulus. And let's find our variance. The variance is the square of what? The deviation from the mean. That is, our variance is what? Summation x minus x bar all squared all over n, or summation f into bracket x minus x bar close bracket all squared all over summation f. So when we are given, we first of all find what? Our mean. From the mean, you can see our formula, our deviation d, which is what? X minus what? X bar. The difference between each of the values and what? The mean gives us our deviation. Then because you are finding our what? Variance, you square it, each of your values, and if there is frequency, you multiply by the frequency, add it, and divide by what? The total number. This gives us what? Our variance. And then the last is what? Our standard deviation. What's our standard deviation? The standard deviation is what? The square root of the variance. The standard deviation is the square root of the variance. And the same way we do the variance, after finding our variance, by the time we find the square root, gives us our what? Our standard deviation. So with this, we talked about, let's do a recap of what we have done. We talked about what biostatistics is, areas where biostatistics have been what? Been very useful to us, functions of biostatisticians, and also we dived into what? Data set, what are data? Types of data. We talked about what? Data by what? The types, and data by what? Level of measurement. I will say data by types is what we have qualitative and what quantitative. Then data by level of measurement is our, from the order is our ordinal to data by measurement is from our nominal to the ordinal to the internal and what? The ratio. I will also explain what qualitative data are and what quantitative data is. And also we said we went to measure of, we talked about what are descriptive statistics, which is a display of data, either in bars, in charts, in graph. And this led us to what? Line graph. Also led us to pie charts. We have our bar charts. We have our what? Histogram. And I told you the difference between our bar chart and histogram is what? There are what? Spaces between them. From there, we moved to our measure of central tendency. A measure of central tendency mostly talking about what? Our mean, median, and what? The mode. The mean, the median, and what? The mode. Then from there, we move to what? Our measure of dispersion. The measure of dispersion is our range, mean deviation, standard deviation, interquartile range. We have interquartile range and the rest. So we explain what our mean deviation is. What is mean? We said another word for mean is what? Average. Another word for our mean is what? Average. When we talk about the mean, then from there we'll move to what? What the median is. The median is the middle number of a set of data in an ordered set. That is, before you can find the median, you must have arranged it either ascending or what? Descending order. Then also talked about the mode. The mode, which is what? The number with the highest frequency. Then went also straight to our measure of dispersion. We said it's what? The degree to which a data set is being spread about the mean. I'll share the material with you. Please indicate, like I said before, your name, your username, your center. So please see you next class. I remain your humble lecturer, Mr. Wilson. Have a lovely day. Thank you.